information you want things to know. It's a principle where you just basically want things to know as little as possible. What's that called? Oh, this is the actual speech. Oh, great. Not when we wanted it. Well, I'm trying to talk about something else. Or someone else playing. Someone found it. Well done. So the law of Demeter goes like this. That essentially, inside a class, inside an object, you want that object to know about its own internal structure. If you're in a method, you're allowed to know anything about the parameters that have been passed into you. You're allowed to know about your own attributes, but you shouldn't really know about anything else. So literally, this gives us loose coupling, which we've talked about before. Loose coupling. More formally, the law of Demeter for functions requires that a method M of an object O should only, it says law, but of course you can break it. It's just a sort of general principle. O should only know about O itself, the parameters to the method that's being called, any objects created or instantiated within the method, your own attributes, and any global variables. Okay, so to that end, and sometimes it's called the law of one dot. You don't essentially want to see dot, dot, dot. And you were seeing that before. Do you remember before when we had a method in, where were we? We were in customer, and the customer was getting, doing a get, a loan, a rental, and then the rental was getting something else. And there was just this sequence of dots of functions returning an object that you then call a function on that returns an object you then call. And so by moving it across the class, we remove one level of dots. And that was really good. Let's now look at, we're getting closer to the idea of getting rid of that switch statement, which we hated altogether. So let's have a look. We'll skip over a whole lot of steps. He does a series, he also, if you remember, well, you see it here? Yeah, you can see it here. I'll just flip across. We've moved one bit of calculation away. That was down here somewhere. Total amount. Up here, and before then, it was a huge switch statement, generating a whole lot of stuff, and all that's being collapsed into one little function call that occurs in the middle here. And this is looking much, much nicer. So we got rid of. But as well as that enormous switch statement, we have this disgustingly complex thing here, which is calculating frequent render points. Again, mixed in the middle of all the formatting. So we do the same trick, that we use the extract method to pull it out, and then we use move method to move it over to the appropriate class. Let's look, which class should this code all go in? Each is a rental. So it looks at a rental, it gets a movie for the rental, and it gets the price code for the movie. So you can see by the law of Demeter, it's doing a bit too much here. Yeah, we really don't want to see these two dots, we'd really just rather see one dot. So it's accessing a rental, it's accessing movie, it's accessing a rental, and it's updating a local variable. Okay, so it's only using local variables and attributes out of movie and rental. It's using nothing out of customer. So again, we do the extract method to pull it out of here, down below, and then we use move method and we move it across to the, I guess, the rental class is the sensible place to take. And that gets us rid of one of these dots. And that's going to give us code that now looks like, page 32. Oh no, there's just lots of analysis and talking about lots of interesting things. Well, oh sorry, this is the looks eventually like this. Here's our statement code now. So it goes, give me all the rentals, use a string called results, loop over the rentals as long as there is one, and print for each rental this piece of information, and at the bottom print summary information which we calculate by calling this function and this function here. This is the method that we've extracted and moved to another thing. get total frequent render points. So all that crap that was in the middle before now is called in this function, which is in a different way. So notice now, the statement fits on one screen, which is good. Is it 10 lines? It's still a bit long, isn't it? 1, 2, 3, 4, 5, 6, 7, 8, 9, it's looking a bit long. But you can see it's much more sensible. And often for things that do formatting, they are a bit more complex, because you literally want to write the lines in the order they appear. But if too much complex stuff is happening, I guess you could pull the footer lines out and have a footer function, couldn't you? And you could pull the preamble stuff out and have a preamble function that prints the top, and you could have some little function that prints out the line for each thing, and then you could just have your statement could then just be as simple as print out beginning bit, then for each rental, print out rental line, and then print summary. You know, it could then be a 4-line.
There's a thing with that. With formatting, just doing the Roman thing, if you start breaking everything up like that, you end up with one method, then 50 other methods
Yes.
just to print stuff out. So maybe it would be easier just to have a 20-line block of code.
Yes, that's right. That's right. Sometimes the reason you would pull things out is if they were doing a coherent lump of stuff that made sensible to call by one name. Don't pull things out just to reduce the function length. If everything's happening at the same level of abstraction, and you have to print this, then that, 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 then sure, have one line to do each of those things. But if conceptually you think about it as do a footer and do a body, then it's probably worth breaking into a footer and a body function, because that will give you also flexibility in the future if you ever want to change the footer or use that footer on something else also. But yeah, for formatting stuff, sometimes you do get longer programs, that's fine. Yes?
How important is the one dot rule?
It's not completely important. That's why I didn't like saying it was a law. All of these things are just hints. What they are, the only thing that's important is we want to write code that's not brittle, that's going to be easy to change and is easy to understand. That's it, full stop, end of story. You can break every law in the whole universe, as long as your code is easy to change, isn't going to fall to pieces when we change the spec, and people can read it and it's clear and it's correct. I don't care about anything else. So everything we're going to do, because over the next couple of days we're going to be looking at lots of laws and principles and smells and things like that. They are only there to help you. They're just hints that say, when this is happening, it's usually bad. If you want to do it, you still can, but make sure you've got a good reason. Just be aware that when this is happening, it's usually bad. So the one dot principle is usually bad because you've normally got tighter coupling in between your classes. And when something changes, you're probably going to have to change both of those classes. And that's not what we want. It's just a rule. It's funny, it's wrong. It's just a principle. Should be. Demeter's hint. Okay, so what are we up to? Yeah, so I want to show you all that, how to simplify it, because after doing all the refactoring, he then wrote the HTML thing. That's what I was jumping ahead to show you on page 32. And not 31, and 32. And you'll see the HTML output is now, the HTML function was turned out to be then trivial to write. Because he only had to change the formatting parts, he didn't have to change any of the calculation parts. So it looks very, very similar, but now it's putting out HTML stuff. But it's using the same computational functions, which now belong in the right side. It's a very simple example, and you probably wouldn't bother to do it on such a small example, but a big example takes pages and pages and pages and pages. He wanted a small example that he split into a chapter. But hopefully you get the idea. Now I have this same problem. I want to talk about my chess program for a second, before we get on to getting into the switch state. In my solution to chess, I'm looking forward to seeing everyone else's and how you guys did it. I had a piece class. Who had a piece class? Now it started off being a piece interface. And in the piece interface, and my piece objects that I made that complied with this interface, as I looked at them, as it grew bigger and bigger, I realized they were doing 3 jobs. My pieces had to sort of look after where they were, so my pieces kept track of where they were on the board. My pieces had to compute where they could move to next. They had to know all the rules for moving and taking. So they knew about movement, they knew about their location, and they also had to print themselves out. So when I printed them, I could print them out. And when I was looking at it, I was thinking, this is too big for one class. These pieces sort of have 3 responsibilities. That's no good. And it was making everything fairly big and cumbersome. And then I looked at the extension exercise, which was to generate a graphical image of the board. And suddenly I realised, oh no, now my pieces have to know how to print themselves out as text objects. They also have to how to print themselves out as graphical objects. And I thought, oh no, then what if I had to print them out another way? And what if someone in the future asked me to print? And suddenly I thought, oh, this whole display notion of how a piece can be displayed, that's almost a job in and of itself. So I decided to break my pieces down a little bit. Oh, and the other problem I noticed was I had heaps of duplicate code. They all comply with the interface, but no matter how I wrote it, I couldn't get rid of all my different all the different classes that implemented the piece interface, like rook and king and queen. I couldn't stop them having lots of duplicate code. And I was using delegation to do most of it. I had something called an iterated mover object. And an iterated mover object, if you gave it a start square and a direction and a chessboard, it worked out all the squares in that direction until it hits a piece. And it actually included that piece if it was an enemy piece and you're allowed to take it. So with this iterated object, it did all the complex calculation. So my pieces became most of my pieces, except the pawn, became very, very simple then. But still I had this great crud of repeated code in each one. So eventually I decided, I just can't stand this duplication. Because code smell number 1, we haven't hit code smell number 1 yet, or we've sort of talked about it. Talked about 2 and 3 and 4. But number 1, the most important, is we hate duplication. When anything's duplicated, that's an indication that something's not right. For the reasons we talked about before, that in the future you'll update one and not the other, and also you've got commonality in 2 different places is confusing. It should be in one place, everything just happening once in one special place. So then I eventually decided I'd have to make piece not an interface, it would have to be a class. Because I always like starting with everything in interface and only make it a class, but I have to make it a class. I'd rather not, because I'm always suspicious of inheritance. So what sort of class do you think I made it first? A piece class. An abstract class. Why did I make an abstract class? Yeah, they're all different. If I can't make an interface, I'll make an abstract class. It's only if I can't make an abstract class, I'll make it a concrete class. Because as soon as you make it a concrete class, then some idiot's going to make one of them one day. And you're going to have a piece object. What is that? It doesn't make any sense. And so you give it some default behavior, like a piece object is a pawn or a king. But then that's hopeless, because then you're saying everyone else is extending a pawn or a king, and the queen is a king. Or, that doesn't make any sense. So the whole is a thing didn't work. So I made it an abstract one, and that was very painful for me to do, because I really wanted to leave it as an interface delegation. Now, who made an abstract class? An abstract class. Okay, who made a concrete class? If you made a concrete class, did you try and hide the constructor or something to stop people making it?
No, all I did was the get move function, or whatever. It just didn't do anything in the piece, and then you just overwrote that function in the subtype. I don't know if that's a good idea, but it worked. What
if someone made a piece though? What would you do? It would just sit still all the time.
Yeah, it just wouldn't go anywhere. So I wouldn't question it, but
I had a dog like that once. Yeah. Do you see what we're thinking? That the advantage of abstract is no one's going to make this damn thing. Because once they make it, it's supposed to have meaning.
Can you just refresh what the abstract, how it works again?
Yeah, abstract means you put the word abstract in the definition. So instead of saying public class piece, you say public abstract class piece, and you give, in a normal class, you give the type signature of the function and the implementation all in one thing, rather than C. Remember in C, you just give the type definition and semicolon.
Yep.
Do you remember that?
Yes.
Yeah. So with an abstract class, you only give the bodies of some of the functions and you leave some of them out. You give the type definitions of all the functions, open a curly bracket if you're going to give the actual implementation, or just type definition semicolon if you're not going to. If you're not going to, you have to add the word abstract to the function definition, so Java compiler knows you're not making a mistake. So you'd say public abstract class get moved.
Yeah,
and that means no one can ever make one of these, but when they inherit it, they get the common code.
It makes sense. That's what it should be.
Yeah.
Maybe I'll change it before it's unified.
Well done, Liam. So that was. Yeah. I found the chess exercise very, very interesting. So I'm going to release all my code, and hopefully we're going to publish everyone else's code, and everyone should just look at everyone else's chess things. And I hope you all started now on the next one, Design Task 5. design, and I hope you've noticed that design task 2, design task 4, and design task 5 are really all similar. They're all inheriting from a common super task, which is abstract, so I never actually go to. They're all the tasks about designing with objects. And I do want to make sure that you can design with objects. So please, if you didn't do well in task 2, you didn't quite get task 2 sorted, and you didn't do so well in task 4, can I just encourage you to try really hard to get task 5, have a good whack at that? Because we won't be doing any more OO, that sort of a Java level design. We'll be looking at more general design after this. So it's really cool if you can get that sort of whole physical modelling thing happening with design task 5. And now design task 5, as you know, you've got 2 weeks to do. The spec is out, though it's a very vague, wishy-washy spec, isn't it? Some people said, can we start? The answer is yes, start.
Especially with silent labs.
Especially with silent labs. It's really hard, isn't it? So, so how did you do it? Laptops. Yeah. I followed the other one. So forgive me, however you solved the other one, that's how you solved this one. Hopefully. And hopefully it was coming out. Yeah. It's very difficult, isn't it? That's just the sort of diabolical levels of interaction you get with this crazy diabolical course. And that was all from your class reps. They said to do it that way. Oh, you're a class rep. Okay, let's now return to talking about, refactoring. Again, this is from Martin Fowler's excellent book from the first chapter. And we're now about to look at how to flip out that switch stuff. So let's go straight away. Alright, here's our rental class and here's the offending code. And I know you've all been itching to get rid of this. This horrible case statement is switching. Why don't, it's like it's just an if, it's the C crappy if thing. I can't believe it's in Java. Please don't use it in this course because it has these breaks in it, which are just begging to be left out by mistake, and it is a non-structured construct. It's completely abominable. When you play it backwards, it's country and western music. So, yes, in this course, do ifs. But we won't even see switches and cases hopefully in this course at all. I'm hoping they're not going to arise very often, because whenever you see them, it's usually an indication that a bit of refactoring is needed. Here we're doing, to carry out one task, which is get charge, we're saying get charge is really one of 4 different tasks, 3 different tasks. It's this task if we're talking about this sort of moving, and it's this task if we're talking about this sort of moving, and it's this task if we're talking about this sort of moving. So what does that tell us? What's our feeling now? The method should be in movie. Yeah. No, but you're sort of right. The selection here, the person making the decision is someone in rental. And really, the decision about which sort of movie a movie is something that movie knows about. Rental shouldn't be making really important decisions like a switch like this, which is switching between, it's either this, or it's this completely different thing, or it's this completely different thing. That's a fundamental decision. It shouldn't be making a fundamental decision based on data in the movie class. If you're ever going to have a switch, you should at least be switching on information in your own class. So yeah, absolutely, we should move this across to the movie class. And then later on, we're going to actually solve it with polymorphism. We're going to get polymorphism. We're going to have different functions doing different, we're going to have different objects implementing different functions. That's how we'll eventually do our switching. But let's first of all just move the switch across. Now, okay. There's a couple of different steps to be done in moving it across. Let's just check which one he does first. And tippy. He just, okay, first of all he just moves it straight across. Okay, so it's over a movie now. The advantage of that is we're switching based on something in movie. slightly more painful for looking up stuff. We now have to look up. We now have to look up. We have to look up something in another class before we got for free. Can anyone see a reference to another class here? Oh yeah, we have to pass in days rented now as a parameter. Before we just knew it because it was an attribute in rental, but now we don't know anything about the number of days rented. So we have to pass it in as an extra parameter. So there's a slight bit of work we're borrowing from another class, but the important switchy thing is now done in our own class, and that's good. Why is it good? Why is it the case that why are we happy to borrow the number of days rented from another class, but switch on our own class, rather than get the number of days rented from our own class and switch on information in another class? No matter how we do it, we're going to be accessing two classes. Why do we prefer to put this in? Why is the switch the most important one for us?
The definitions of those constants is in the movie class, so you don't want to be switching them.
Yes.
Yeah, mixing them.
Yes, that's right. Can I rephrase that? Remember I said we're going to be changing a whole lot of stuff. We want to have it so that when something changes, we just have to make the change in one spot. What's most likely to change? Something about the number of days rented, or something about the types of movies we've got available? No, the number of days rented will change, but it'll always be an int, won't it? I mean, it's just essentially just going to be this number that's passed in or out. It's hard to imagine how anyone could change the whole days rented system that'll need to change the code. But it's very likely that someone's going to invent a new type of movie, because the customer even told us that's what they're thinking of doing. Remember they said pretty soon we're going to be introducing some new movie types? So it's already on the cards that that's going to be changing. So when new movie types come in and things change, we're going to have to actually add extra lines of code inside the case statement to deal with it. So it's going to involve function rewriting. We only want to be changing one class. When movies change and movie types change, we only want to change the movie class. We don't want to have to change movie and also change rental. Does that make sense? So it sort of makes sense here because we know what's about to change. So let's group all these things together. They're sort of more closely related. Okay, so now once we've done that, I just want to get to the exciting bit. Just doing it in tiny little baby steps. Here we go. We're finally there now. Are we? Oh no, yes, one more. He moves the frequent rental point calculation across as well. Remember it was that disgusting thing with plus pluses and things? Now it's just simply, you either got one plus plus or two plus pluses depending on if you're an overnighter or not. Now, it simply returns a 2 or a 1 depending if you're, if you get a new release and you rent it for more than a set number of days, you get 2 movie bonus points, otherwise you get 1. And if that logic ever changes, then, what's he done? He's extracted the method. Oh, he's got to move it across to the other class, isn't he? What class is this in? This is in the rental class. And it's doing get movie, get price code. Yeah, yeah. Oh, you can see it at the bottom. Yeah, I'm just thinking rental seems a fine place to leave it, doesn't it? Yes. No, it was in report. Wasn't it?
I think it's in customer.
Oh yeah, sorry, it was in the report function in custom. Yeah. Being in rental makes more sense because it uses the number of days. It does access a movie type, but not really intimately, does it? It's quite possible if he adds a new movie type, this won't have to change. Maybe he's only going to hand out points for movie new releases, but the other types. Okay, now that we've moved the functions to the classes where we'd like them to be, where they seem to make the most sense, we want to deal with the fact that we have this ugly switch. And we want, instead of having the switch, we want to have polymorphism. So we essentially want to have a couple of different objects. And if I use this object, suppose I've got a an overnight rental object. If I've got a movie which is an overnight rental type of movie, then when I say what's the price, it'll have one definition of what the price is. And if you're a children's movie and I ask you what your price is, you'll know your price. And if you're a normal movie and I ask you your price, you'll know your price. So there's no need for a case statement. The switching is what object I've got. If I've got that sort of movie, I just ask it what price it is and it tells me its price. This is object polymorphism. Polymorphism means you can use different objects inside the function and everything still behaves sensibly. The function can have multiple types of objects. So I get the different functions for free because the functions are attached to the object. Does that make sense to everyone? That's our sort of objective object. Okay, now there's an interesting trick though to think about. Let's go back to chess. I simplified the rules of chess quite a lot. Did you notice that one of the simplifications was pretty key? I said, can anyone guess what was the most important simplification? I know the most annoying one was working out what the check rules meant. But there was one simplification that had a massive impact on your design. You might not have even noticed. Pawn? Yes. When we said don't worry about what happens to a pawn when it reaches the end. Because in normal chess, what happens to a pawn when it reaches the end? Changes into another object. Now, if you've made a rook class and a bishop class and a king class and a queen class and a pawn class, and you've got an object of pawn class and it reaches the back row, what would have to happen? It'll have to change its class. You can't create a new object, man. You've got a reference to that one. You can't. It's like how do I explain this? A reference is like an address, someone's address at someone's house. So at this address is an apartment block, and at this address is a concert hall. And the apartment block's got to change. I don't want it to be an apartment block anymore. I want it to be a concert hall. But once you've got, so Kitten sitting over here has the address. You've got the reference. Someone said, go to this place on Sunday night. You're about to go to that place. He's got the reference to that place. That place is you. You're an apartment block. But you've reached the back wall. You've got to turn into a concert hall. I can't destroy you, create a new object with the exact same address and magically everything will work. That's not how Java works, is it? I could make a new concert hall, sure, but he's over here. You're not going over there, and there's no way for you to tell him to change his address because references only go one way. There's no way of saying, oh, tell every object that's pointing to me to now point to someone else. It'd be nice if you could do that, but you can't. So it would be this complete nightmare. How could you have done it if your pieces had changed type? Knowing you can't change the type of pieces in Java, how would you have handled that? But if you delete that piece, well, no, but someone might have a reference to that piece, mightn't they?
You would give it a new object.
Hang on a second, I just want to, I think, what's your name? Symphony or Symphony? Symphony! Ah! Symphony 1. Is that right? Yeah. And Symphony said, look, you could destroy it. It's stored on the chessboard. Put another piece on the chessboard. And I think the reason she said that is she knows that the way that her code uses the chessboard is it doesn't keep persistent memory of any pieces it's ever used. Every time it wants a piece, it goes and looks on the board again. So if you did change the board, it would be okay. It's like saying, Kid knows he's going there tonight, but he doesn't bother remembering the address. He just carries it in his address book. And we have access to his address book. So we destroy and demolish you, build a new one over here, change your address book to point to that one, and then when tonight you look in the address book, yeah. But if you had a good memory and you didn't bother looking in your address book, you'd go to the old ruin site. So can you see that? That sort of was possible because you knew how the objects were going to be used. But in general, that would be a dangerous thing to do because you normally don't know. It's the whole API thing, the ADT thing. You don't know how someone's going to use you. So they might have a pointer pointing at you. And, yeah. But that's not a bad way. But what if you wanted to have it that a piece could actually change? And it could go from being a queen to being a pawn. If it wanted to.
You give the pawn a queen, and then every time you access the
Oh! Okay, this is good, this is good. Did everyone hear what George said? He said, You would give the pawn a queen. And then whenever anyone asked the pawn what it was going to do, it would just delegate it to the queen object. That's very clever. And only pawns would have to have this delegatory power. That's very clever. I like that.
Yeah, but you'd have to include every other case because the pawn can get to the end and change into whatever it wants.
Yes, but that's all right. You just store a piece. Inside it, you'd have a method called an attribute called piece I changed into of type piece, and somehow that would be decided. I mean, the player has to decide what piece to turn you into, so the player does have to know all the possible pieces. The player turns you into that piece, and then whenever you get a call from now on, you delegate it to that one. That's a nice solution.
It's only bad if the pawn can turn into a pawn and then turn into another object.
But the pawn can turn into a black pawn. A white pawn can turn into a black pawn. There's all these good rules you can make to turn up. All right, so that's a good way of doing it. Can you see that solves that particular case? But it probably doesn't solve the general case. If what if any piece could change into any other piece? Like, for example, what if an overnight movie could turn into a weekly new release movie, could turn into an action movie, could turn into a comedy, could turn into a kids movie, like movies do as they age?
How about make the piece has a bit color and bit height?
Yes, that's right. Thank you. What's your name? Chen? Tran? Yeah, Tran. If I've got what you said right, Tran, tell me if I've got it right. Essentially, we have an attribute of a piece saying what its type is. Is that what you're saying? We call this approach the state pattern. This is the state approach. So instead of all the state information being stored in the type, in the actual class, the class actually does a hasr and stores another object that contains the state information. So if you did it that way, your pieces now could only worry about their location and how to draw themselves, and they would store something called something of piece type. And piece type could be queen or rook or bishop or whatever. And then if they change, you just change the piece type that the object has inside. Does that make sense? And then all movement functions are delegated to that, or that does the movement calculations. And that's a very nice way of splitting the responsibilities down. And it goes a bit of the way to alleviating my concern that piece has so many responsibilities as well. So that's very nice. Now we've got the same problem with our movies here. We could, the naive approach would be, you might say, all right, well, let's have a movie class, or maybe make it an abstract class, and have subclasses of it, or an interface even, and have subclasses of it called weekly new release, overnight, regular loan, children's movie. And then put all the information about price and frequent renter points and things in these subclasses, and then use these subclasses instead of movies, and pass them around instead of movie objects. But can you see now that's not a good solution, because we want really our movies to be able to change what they are. So we probably want to have a movie class that stores inside itself some sort of movie type, where a movie type is now another sort of class that we have to write. And the movie type will have to know the cost of that movie type and the frequent renter points for that movie type. And a movie doesn't have to know that information. So a movie will hasr movie type. Does that make sense? And that's the final refactoring. Once we've done that, now yourself could now do it. Convert that case statement to a class called movie type, and then your movies would have a movie type. Can I say there's only one trick in that conversion that you have to get right when you when you actually make these different movie types. You look at all the existing code. Number 38. Where are we? Oh no, my notes are so crappy here, I can't actually, I was trying to jump ahead there a little bit. I'll leave the beautiful picture of the book up there so you can see it. I'll just say what the, rather than be hunting around and finding, I'll say what the trick is. The only trick is, At the moment, we've got some sort of code representing movie type. Remember, it's an integer. I think 1 represented it was an overnighter, and 2 represented it was a this, and 0 represented it was a general movie, or something like that. And we had functions to get the movie type, and they just looked up these constants and returned them. And we had a function to set the movie type, to get the movie type of the movie, and that depended on what movie it was, it looked up the right one of those constants and returned it. If we're going to stop having the constants, because the idea is we're not going to have those constants 0, 1, 2 as important things anymore. What we're going to have now is objects that store those codes inside them. And they're going to be our movie types. So we're going to have a movie type kids movie, a movie type new release movie. And they'll have something called get code, and they'll return their own code when you call the get code on those objects. And they'll also return their price, and they'll also return the frequent price. You want to make sure when you move accessing those fields, essentially, let me say it more directly. The problem is at the moment, some information is stored as an attribute. It's stored as something called movie code in one of the classes. And you can access it by just reading the movie code field. Oh, let me show you in the class. Let's actually go. Back. Where we start. Okay, for example, let's look at customer name, let's look at rental, let's not worry about rental, let's look at movie. Okay. The price code, it's called. The price code is stored as an attribute. If other people want to get hold of the price code at the moment of the movie, if anyone from outside the movie class wants to get hold of that price code, how must they get hold of it? Using a getter. So, if now movie no longer stores that as a field that's an integer, but movie has an object that's a more complex thing, we can just change that getter to query this object, rather than querying a private field that's an integer. Does that make sense? So the outside world using us won't notice we've changed the representation, and all our code will continue to work, which is exactly what we want. Maybe we want this incremental refactoring. So the fact that the rest of the world is using a getter is a wonderful thing. If we had instead said public int price code, and people had been accessing it by just reading it directly, they've been saying movie.price code, there would be stuff now. Because we no longer want to actually literally store the price code ourselves. We want someone else to store it. We want to delegate access to them. And anyone else that is now reading our one directly will now always be getting the wrong one. Will not be getting the... Does that make sense? In other words, if we'd made that attribute public, we can't change it. Once it's public, it's in the API. Other people will use it and start relying on it. So it's a big change to our code to change it. And if we, instead of storing it, want to calculate it, which is what I'm saying we want to do now, calculate it by referring to a delegated object, we couldn't do it. We've lost the ability to do that. Does that make sense? We'd have to go through the whole code base, and everyone that had accessed that attribute would have to now force them to use a method to get hold of it. But if everyone did use a method, woohoo, we're in, because we just changed that method to do whatever we wanted to do. It's exactly the same example as we were talking about with Kitten before. If you were getting hold of that data because you literally stored the data, then we have no hope of ever being able to change what that data is talking about or anything about that data. But if you only access that data by calling a method that he has, then we just change his method, and next time you access the data, you're getting redirected and getting the data in this other fancy way that we want to deliver. That's a good design. So thank heavens we did it this way. This means now, because we use getters and setters, that we can change our own representation of how we're storing it, and all the other classes in the world will still work and nothing will break and everything will be great. Woohoo! Because that's exactly what we want to do. Except, can you notice that we don't always use a getter or a setter? Can you see somewhere that the attribute is accessed directly? In the constructor. When you build the movie, we access the underscore price code field directly. What we're hoping, what we would want in our dreams, is that underscore price code appears nowhere in the whole universe except here and in the getter and in the setter. If that's the case, then we can change the getter and the setter and change this, and no one will even know. No one can get hold of what's happening underneath, so they'll never know. But unfortunately, our constructor accesses it directly, So that's not going to work. We can't suddenly change things because our constructor depends on it. How should we have written the constructor? It should have called the setter. What should it have said? It should have said set price code, which at the moment would do exactly the same thing as this line, but it gives us the freedom to change things in the future. So this is what's known as the uniform access principle. You should never let anyone get hold of your attributes. You should make sure they can only get hold of your methods. And if you want them to access an attribute, give them getter and setter methods. The idea of the uniform access principle is this, that you don't want anyone using your class, so anyone using you shouldn't know how he's implemented anything. He should be free to implement things however he wants. And sometimes you'll choose to store a piece of information as an attribute. Sometimes you'll choose to compute it, maybe by delegation to another class. Sometimes, and this is the thing that Theo was hinting at before, maybe sometimes you'll compute it and you might cache it locally, keep a local copy, and the next time someone requests it, if it's expensive to compute, you might first check to see if anything's changed, and if nothing's changed, you might say, oh, I'll just give you the answer I worked out last time. You have the freedom to make these implementation differences as long as everyone's accessing you as a method. But as soon as someone accesses you as an attribute, you can never change it. You only have the choice of using an attribute. Whereas if they access it using a method, it can be either backed up by a method or an attribute. Does that make sense? That's the uniform access. Oh, I've just said the time, 6 o'clock. Okay guys, I'll see you on Thursday.